Okay, hello everyone, and thanks very much for the opportunity to speak at this event. My name's Tom, and I'm from the National Archives. I'm service owner of Web Archiving, and I'm joined by Federico, who's from the Alan Turing Institute, and we're going to talk to you about an interdisciplinary collaboration that we took part in towards the end of last year to discover topics and trends in UK government web archive. So here's an overview of what we'll cover. I'll do an introduction into the web archive, and then we'll get on quite quickly into our current full text search service and some of the limitations that exist for our service as a web archive in this respect. And then we will talk about some of the research and challenge questions. Also the data preparation, which was a very important part of the process, tools and approaches used during the week, and then finally some future work, reflections on what we'd like to do next. So the UK Government Web Archive is a publicly available web archive, and you can visit it there. It's a large archive of UK central government websites from 1996 to present, and we decided to join with the Alan Turing Institute for this event, the Data Study Group, December 2019. You can read about it. You can read about it there. But basically, it was a collaborative endeavour to tackle some problems, some challenges that we came up with in relation to finding resources within the UK Government Web Archive. So the Web Archive is made up of more than 45,000 crawls over nearly 24 years, and that's about 6,000 websites. It's about 160 terabytes in size and 6 billion resources. Each of the domains that make up the archive, whenever we crawl them, in general, we aim to archive the entire site each time. It has a powerful full-text search tool, and it's fully open online and is accessed by millions of users. It's a vehicle, as an archive, it's useful for us to see this as a vehicle for collection, preservation, and for access for digital records. But it is also a contextualizing tool for showing what was released to the public domain alongside other records which have been released, say paper records or born digital records that have been released or are to be released in the future. So here's some examples of the types of websites we are archiving, but we're also archiving social media. At present, we take Twitter, YouTube, and Flickr accounts, and we are researching into archiving other social media platforms as well. So searching. So as I said earlier, our full text search service is useful and it is well used. However, there are certain limitations of full text search. Definitely in the case of the UK Government Web Archive, and probably to other web archives too. So duplication and near duplication is certainly a challenge, particularly when you're dealing with a large corpus of documents. Duplication is relatively straightforward to detect and to eliminate if they are truly identical. Two things are truly identical, but near duplication is more of a challenge without having any false positives and removing unique content from a full text search index. There are limitations of filters, and this kind of runs through a lot of our motivation in doing this research, because filters require some domain knowledge. So, for example, the user may need to know what they are looking for to find it in the first place, and I think this is one of the unlocking this domain knowledge is one of the challenges, and when we come onto future work, I'll mention that. But if I or one of my team were looking for a particular resource in the archive, we would use a number of techniques using our domain knowledge that probably the average user, member of the public user, wouldn't necessarily be able to use. So it's quite a big issue. There's also the handling of changes over time, so both structural and semantic changes. So where content sits, how government was organised, but also the sort of meaning behind various, languages and how language and how that changes over time between from year to year or even decade to decade. And then there's a lack of search ranking or weighting in our current search service, which is actually a deliberate decision, which is very much about not wishing to lead users towards documents that and at the cost of finding other documents. And above all, there's the challenge of scale. Of course, we need some scalable sort of machine-driven solutions to this. We can't manually annotate over 500 million pages and documents. So data selection and preparation is really key, as I'm sure you'd imagine. We decided to select our data using a few principles. Basically, we wanted to draw it from across the Web Archive and represent the temporal sweep of the archive, but also be large enough, but not incredibly large, so that we wouldn't be able to deal with the resulting data in the week, or actually the few days that we had to look at it. And this was all just to make sure that the data was as representative as possible. So we had 4 separate data sets that were derived from HTML pages only in the Web Archive for this challenge. Government hub websites, so direct.gov.uk and www.gov.uk, with JavaScript removed. Dataset 1 raw was the same, but without any pre-processing. And then we had dataset 2, which was thematic sampled websites from around 450 government websites, which were pre-selected through using high-level topic modeling. And then finally, we had some supplementary websites as well, all the home pages and a selection of blog sites too. So our research and challenge questions are these. I won't read through every one, but essentially we were interested in evaluating the how effective natural language processing tools, NLP tools, were in unlocking some of these challenges for us. So if we were to be able to spin up a very large cluster of machines and to crunch through the Web Archive, what hope should we have that something immediately useful could come back? The other issues were a little bit more detailed and sort of nuanced, really, were about this semantic change, the emergence and evolutions of topics and meanings within the Web Archive. How can we unlock that and so on? And then the other aspect of it really was how do we present this to our users? How do we present what this is all about? And basically, ultimately, we would have to explain the limitations, but also be transparent about the ways in which the tools had been developed.
And I'll give you a quick overview now of our experience at the data study group, the things that we approached, the issue that we faced, and some of the approaches that we used during this week of collaborative work at the Alan Turing Institute. So we were a group of around 10 participants with a background spanning from digital humanities to data science, mathematics, and statistics. We were PhD students, postdoc, and a couple of research software engineers. We met for the first time at the beginning of that week in December, and we began our data study group with a meeting together with the team from the National Archive in order to understand the task define a few milestones to approach during the week, and clarify what was delivery that will be useful for them at the end of our week of hackathon together. In particular, we decided to focus on improving the search algorithm used on the National Archives Web Archive website, and to be able to move beyond string matching approaches, and in order to offer a sort of semantic or topic-based search through the use of entities and concepts. To do this, we first decided to focus on enriching the collection with named entities in order to allow the user to identify documents that are speaking about a specific entity, even if it's not mentioned exactly with those words, or in order to recognize similar concepts and ideas across different documents. To do so, we use the Spacey library in Python for doing named entity recognition, and the first couple of days were mostly focused around finding an efficient way to parallelize Spacey in order to enrich the corpus. We decided at the end to focus on the so-called raw corpus because we wanted to have a version of the dataset that was as original as possible, and then we identify a subpart of the raw corpus to conduct named entity recognition. Finally, we employed a simple heuristics to disambiguate entities against Wikipedia, and being able of recognizing, for example, that different entities were actually referring to the same Wikipedia entity. The second part of the data study group, we focused on allowing search of entities and concepts beyond string matching. So instead of matching and retrieving documents if they are mentioning exactly the same string, we wanted to allow the user to identify cases in which you are talking about a specific entity by using, for example, a different way of calling this entity. To do so, we used doc2vec, so another Python library, and in particular we decided to focus on the use of word embedding to define vector similarity between the user query and the documents that are retrieved. We conducted evaluations both on the recognition of entities and the similarities between document and queries. We realized how hard it is to work with documents that are raw HTML pages, especially because when you do entity recognition, you will recognize entities also as HTML tags, and at the same time, this will add noise when you are doing doc2vec representations. We finally studied also if it was possible to use this vector representation for cluster documents based on a sort of semantic similarities, and also to use them to recognize, for example, specific trends or some sort of semantic change in the collection over the years. Finally, on the last day, we tried to summarize all these ideas together in a simple prototype of an interface where you can input, for example, different concepts or different entities or tokens as separated by a comma, so you can compare their distribution in the collection over time. You can select a specific time range, and then you can see a different type of plots or different type of graphs. And these plots and graphs will allow you to understand and identify entities and topics beyond string matching. So in case, for example, a document is referring to the Olympics but is using the London 2012 name, you will also be able to retrieve this and see its occurrence in the graph.
Okay, so yeah, I hope you got from this presentation that while extremely challenging, we have shown that there is enormous potential in using these approaches for the web archive, for our web archive in particular, and quite possibly other web archives. The following things are, we've given some thought to future research, of course, and what we'd like to do next. So the first one I need to mention really is that we need to do some user research. This will help to inform where we where we prioritize our work. Ultimately, we're trying to support our users in getting the most out of our service. So we need to make sure that we do that with their needs front and center. Then there is a fair amount that we can do to improve existing tools. So the full text search service we currently have could be enhanced with particular document tagging and various other approaches that we are looking into. Encoding domain knowledge is an important feature of any of these systems, particularly given the sort of temporal nature of them. So we know that there's a steep learning curve for users to understand the web archive, what it contains, how it works, and so on. And the domain knowledge that exists within my team, with some colleagues, but also with some, let's say, expert users, is not easy to encode to be deployed with a sort of machine-driven approach, but it would give us massive benefits. So but the kind of thing I mean is what a particular domain or website was about at a particular time and how that changed and maybe handed over to another website with a change in government, for example. And then we would also look to enrich our data sets with third-party knowledge. So this is typically done with Wikipedia data, but there are other potential sources of this kind of knowledge that could ultimately lead into a richer user experience for placing the archive in context and so on. And then cleaning up the input data, the data that we actually use for the challenge and for testing these tools is a big part of the challenge. We want to increase, a kind of a positive signal as much as possible without having too much noise. But at the same time, we know that there's a fair amount of meaning within the structure of websites, within the way the documents are laid out, and so on, that we don't want to lose by over cleaning or sanitizing this input data. So not too much. I think there's a very fine balance probably between what, not too much and too much or too little in that space, but quite an interesting area too. So that's the end of our presentation. Thanks very much for listening, and we'll take any questions if you have them. Thank you.